Okay, so the second video, we'll just go through some simple examples. Okay, I've just whipped out a TJ textbook and we'll just go through some of the questions. Okay, so feel free to pause this video as we go through. You can look at the question, pause it, try and do it yourself, and then see the solution. Or you could, watch a few of the solutions to begin with, and then try and do some yourself. Okay, so very first question is nice and straightforward. Let's see where my pen's gone. There we go. So very first one, we've got x squared multiplied by x cubed. So this was the addition rule we were talking about before. So that's just going to be x to the 5. Okay, 2 plus 3 gives us 5 because we're multiplying, therefore we're adding. So this is x and x, and this is x, x, x. So therefore it's going to be 5x's. Simple. X cubed. That's not very clear, is it? X cubed. There we go. Times x to the 4. Yeah, x to the 7. 4 plus 3 gives us 7. Classic mistake. 3 times 4 and 12. No, it's going to be adding. Okay, let's go a bit further down to the harder ones. X to the 5 times x to the minus 2. It's going to give you x to the 3 because 5 minus 2 gives us 3. The other way to think about that would be to say, well, you've got, remember the other rule, you could say that that is the same as x to the 5 times 1 over x squared. Yeah? So that would give you x to the 5 divided by x squared. Again, sorry, that's a bit not very neat. I'll just try that again. X to the 5 divided by x squared. 5 minus 2 is going to give us x cubed. So that's actually a really good question. That's using a few of our rules. There's different ways to do that. The addition rule, and then this way is using the 1 over rule, because we know the negative on top gives us positive on bottom. And then dividing, we know we take them away. That's very good. That's actually, again, another way of thinking about before when we said that x to the 0 was equal to 1. You could actually imagine that using this rule as well. You could say, well, x cubed divided by x cubed. Well, they're just the same, isn't it? Anything that's the same is going to give you 1. And actually the rule works here as well, because 3 minus 3 gives us 0. So x to the 0 would give us 1. Okay. So, yeah, just a little side thought there. Let's try another, let's do 2 more examples of this one. Okay. What have we got? Let's up the ante. Let's do q cubed times q to the 5 times q squared. Yeah, so that's going to give you q to the 10. Okay, because just adding each of these. We've got 3 q's, q to the 5, q squared, q to the 10. Just adding. It doesn't matter if there's 3, 4, 5, however many there are. We're just going to add each of these powers. Very nice. And let's go for a slightly trickier one. Y to the minus 2 times y to the minus 1 times y to the minus 3. Yep, so that's going to give us y to the minus 6. Minus 2, take away 1, take away 3. We're just adding them all together. Okay, nice and straightforward. But that is useful when we're working with, say, integration differentiation. It's good practice to leave it in this form. Okay, that's a much neater way to leave it. Okay, so if you ever see you've got a negative as a final answer, just change it to this. Okay, it looks a lot better. Good form. Okay, so when we're multiplying, we just add. Nice and straightforward. Okay, good. Now what if there's an integer in front of these numbers? Okay, so let's just draw a line under that. What if now I said we've got 2x cubed multiplied by 4x squared? Well, you would just do the same thing, except the integers follow the integer rules. So we know that 2 times 4 is going to give us 8. Okay, so we can say, well, we've done the 2 times the 4. That's good. And then we're just going to do the same rules for the indices that we just did. So x to the 3 times x squared is going to be x to the 5. Okay. And again, sometimes that throws people because they're doing 2 rules in their heads. They've got their normal indices rules. We all know 2 times 4 is 8. So our normal integer rules. But we've also got our indices rules as well. So this is following the integer rules, just like you've been doing since primary. And this is our indices rules, which we've just done. So 3 plus 2 is 5. Nice and straightforward. Let's try another one. Let's go for 4k to the 4 times 4k to the 5. So yeah, nice and straightforward. 4 times 4 is going to give us 16. And k4 plus k, well, times k5 is the same as k4 plus 5. Going to give us k9. Okay, good stuff. Let's try a slightly trickier one here. We've got 9z to the 12 times z to the minus 8. Well, you can imagine that this has just got a 1 in front of it. So that 9 times 1 just gives us 9, so that's fine. And then z to the 12, z to the minus 8. So we just do z 12 minus 8, which is going to give us 4. Nice and straightforward. Okay. So that's some of the multiplication rules. Some examples of multiplication rules. Let's go for some division rules. Okay, pen. Right. B15 divided by B11. 15 minus 11 is going to give us B to the 4. Good stuff. Nice and straightforward. A to the 11 divided by A to the 7 is going to give us A to the 4. Let's go for C18 divided by C10. Now again, I've written it in this format just to remind you that that is the same as saying C18 divided by C10. So 18 minus 10 gives us 8. So there's nothing really new here, we're just applying our knowledge in a different way. We know how to add, take away, and multiply. It's dead simple. We just need to know when to do it. Okay, so right now you're probably thinking this is dead easy, and it is, but it will just get a little bit trickier when we start to combine some of the rules. Okay, very last one on here. Let's do y to the minus 5 divided by y to the minus 2. So in this case, it's just exactly the same as what we were doing. We're doing the top, take away the bottom, but 2 negatives make a positive. Okay, so this is going to be y to the minus 3 because it's minus 5 plus 2. Okay, so there's a little trick, but again, we know that. Okay, that's first year primary 7 work. Okay, minus 5 plus 2 minus 3. Okay, good stuff. Now let's do, again, mixing this up with some integers. So say we had, say 20k to the 12 divided by 16k. Well, that is the same as saying k to the 1. So I know right away I'm going to have k to the 11 on top. And then 20 divided by 16. So what we need to do is simplify this as much as possible. So what's a factor of 20 and 16? I'd look at that and say 4 goes into them. So 20 divided by 4 will give you 5. 16 divided by 4 give you 4. Okay, so that'd be 5 quarters k to the 11. Okay. Again, for these, a good way of doing it, if you're not great with your numbers, just divide by 2 to begin with. So 20 divided by 2 would have been 10. 16 divided by 2 would have been 8. Divide by 2 again, give you 5, give you 4. Okay, dividing by 2 is always a good place to start if it's an even number. For these kind of numbers as well, a really good rule is the rule of the divisibility rule for 3. So if you've got, say, 21, for example, I know that divides by 3 because 2 plus 1 gives me 3, and 3 divides by 3. Okay, I know that 72 divides by 3 because 7 plus 2 gives me 9. I know that 9 divides by 3. Okay, and it's the same for any number. I know that 111 is going to divide by 3 because 1 plus 1 plus 1 is 3, and that divides, well, 3 divides by 3. Okay, so when you're doing these, a good place to start with is just dividing by 2 and thinking of your, does the number itself add up to 3? Sorry, the sum of the digits add up to 3. Okay, that's a good little trick. And obviously dividing by 5 ends in 0, ends in 5. Okay, right, let's do another one. This one looked good. So we've got 21, we'll put it down here. So we've got 21 q cubed divided by 14 q to the minus 2. Okay, so again, let's do our q's first. So 3 take away negative 2 is 3 plus 2. So I know I'm going to have q to the 5. Okay, 21 divided by 14, that's obviously your 7 times table. So 21 divided by 7, that gives us 3. 14 divided by 7 gives us 2. So 3 over 2, q to the 5. Okay, and I've got like a wee double underline as well. Let's do one more. It's a slightly trickier one we'll do. Okay, so we've got 4 w to the 5 x cubed divided by 2 w squared x squared. So 4 divided by 2, we know that's obviously 2. Straightforward. The w's 5 minus 2 is going to give us w cubed. And then x, 3 and 2, 3 minus 2 is 1. Okay. So again, you apply these rules to the likes for likes. Okay. So 4 divided by 2 is 2. 5 minus 2 is the 3. 3 minus 2 is the 1. Nice and straightforward. Okay. Let's move on to power rules.